Hello, guys. What we're going to be talking about today are normal distributions. Now, normal distributions are distributions of data that follow a particular pattern. So that's the first thing we need to look at is how can you identify a normal distribution and use its mean and its standard deviation to estimate percentages. That's what we're looking at. Now, let me show you some examples for a second, guys. Um, Two measures of variability. Variability is how spread out the data is. So I think of two measures of spread. Variability is a big word. Two measures of spread are the range and the standard deviation. The range is the difference between the maximum and the minimum. It's the biggest number minus the smallest number. We've talked about that. The standard deviation is found by taking each individual data point, taking the mean, and finding out how far they away are they away from the mean, whether they're this far or this far or this far, and then taking the average of all of those distances. So the standard deviation is the average distance from the mean. And if that's a little getting a little busy for you, just think about this. If the standard deviation is big, the data is spread out. It's way spread out. If it's low, the data is not very spread out. That's it. Okay. So, give you an example. Um, Here's a bunch of students in a class. Their average score was 62. I'm not going to ask you to find that, but remember, you would add those all together and then you would divide by how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, divided by 11. Um, the standard deviation was 18. That's a much more complicated formula. I'm not going to have you deal with it. Okie doke. I can always type it into a spreadsheet and just say find the standard deviation. Do something like that. Okay, but today we're not going to worry about that. So what that means is that on average, students' test scores were were about 18 points away from the average score of 62. Means if I was to go 18 more than 62, that'd be like what, 70, 80, and 18 less than 62, that would be 44. The majority of students scored between 44 and 80 points on that test. That's what that means. Okay. Now, a normal distribution, here's where we get to some things. You can identify a normal distribution because it's symmetric, which means it gets split in half, and the right half looks exactly like the left half, okay? Um, and it is bell shaped. Bell shaped means it's gradually going away from here. It's gradually going away from the center. Now, this really isn't perfectly bell shaped because there's these steps. A true normal distribution is a much smoother curve, but its peak there corresponds to the mean and the median, and usually the mode, but this is not always the mode. It's also described by how spread out it is by its standard deviation. Okay, so conditions for a normal distribution. Most of your data points are right at the mean. Okay, giving it a very single defined peak. Secondly, it's symmetric, means the right half is the same as the left half. Now, real life data, it doesn't have to be perfect. We're looking for pretty close. For example, this data you see over here, it's not perfectly symmetrical, but it's pretty darn close. Now, if this was a statistics class, I would give you some conditions of how close is close enough. For today, we're just worrying about, is it symmetric? Is it bell shaped? Okay. Also, as we get further and further away from the center, we look and we see things are becoming much more rare. Okay, see it? Much less common until you get out to things that are very, very uncommon. Okay, so that's what we get, these kind of tapering tails. So single peak tapering off to tails. Bell shaped, symmetric, there's your normal curve. Okay, Now, now, um, individual data, they're resulting from a lot of different factors. We're going to talk about some of these. So, things about normal distribution, things about some things to consider. Let's talk about a couple of these. Scores on a really easy test. Do you think they'd be normal? Do you think they'd be symmetric? A lot of people in the middle. It's a really easy test. That's probably like the last test. No, on that last test, really easy test, I had a lot of people getting really good scores and very few people getting poor scores. That was actually, and I'm trying to write with my mouse, so that's a little harder. That's a skewed left or right? Left. This is a skewed left distribution because it's got a tail on the left. Okay, foot length of a random sample of adult women. Well, if you haven't looked at a lot of feet of adult women, they're not, you don't have a whole bunch of really, really small and really, really huge feet. Most of them are pretty close to the same. This would be normal. You would have a bunch of people in the middle, and as you get to more extreme sizes, whether very small or very big, it would taper off. So this would be normal. So if you consider what would happen in these kind of distributions, you can predict what kind of things would be normal, what kind of things would not. So, in a normal distribution, here's one characteristic of a normal distribution, and the one we're going to deal with today. In a normal distribution, if you were to arrange it where you had the mean in the middle, right here, so this curve has a mean at 0, and it has a standard deviation of 1. So there's one standard deviation, 1 plus 1 is 2, two standard deviations, 3 above the mean. Here's minus 1, that's 1 below, 2 below, 3 below. 68% is plus or minus 1 from the mean. Well, here's that 68%. But since it's symmetric, if I split that 68% into 2, there's 34 on each side. 94% fall within 2 standard deviations. Well, if I take that 95% and I subtract the 68% that's in the middle, 95% is between here and here. There's 95% right there. If I take this 68 away, I end up getting 27%. That 27% is split between this chunk and this chunk. 27 divided by 2 is 13.5. That's how we find how much is between 1 and 2 standard deviations below, and 2 and 3. If you do that same thing with the third standard deviation, 99.7% fall within 3 standard deviations. That means there's only 0.3% on the outside of the tails. That means there's 0.15% up here. That's just about nothing, right? Almost all of your data falls between 3 standard deviations less and 3 standard deviations more. There's 0.15% on the bottom and 0.15% on the top. So that rule, which we also often call the empirical rule, called the 68, 95, 99.7 rule, helps us find percentages in a normal distribution. That's something you want to write down, something you want to remember. 68, 95, 99.7, and then be able to find all of those percentages in the middle. So the area under your curve is always 100% because it's 100% of the data. Okay, now let's think what we can do with that. If I took 2,000 freshmen, took a biology test, their scores were normally distributed with a mean of 70. That means I've got 70 right here in the middle. It's normally distributed. Standard deviation of 5. That means that one standard deviation more would be 5 test score points more, so this would be 75. What would be 2 more? That would be 80. 3 more, that would be 85. If I go down, 70 minus the 5, that's 65. 65 minus the 5 is 60. And 60 minus 5 is 55. Okay, so first thing you want to do with the normal distribution, when you know the mean and you know the standard deviation, is do exactly what I do. The mean goes in the middle, and then you go out 1, 2, 3 standard deviations, label it. First thing you do is label it. Now, what percentage between 65 and 75? Well, 65 to 75, 65 is 1 standard deviation less. 75 is 1 standard deviation more. And remember, our 68, 95, 99.7 rule tells me that between 1 standard deviation less and 1 standard deviation more, there's going to be 68%. So in between that 1 less and 1 more, there's 68%. Now, if I split that up into 2, remember there's 34% here, because 68 divided by 2 is 34, and 34% there. Okay, what about between 60 and 70? Well, 60 and 70, let's think about that. 60 is 2 standard deviations lower. So that's going to deal with the 95 rule because you're 2 standard deviations lower. But if I take the 95%, because I'm only dealing with that part right here. So this is a good rule of thumb. When you are finding these percentages, shade the space. That helps you see it. I'm looking at that saying, oh, well, that's half of that 2 standard deviation thing. If I take that 95 divided by 2, that's going to give me 47.5. That means there's 47.5% here. Let me answer this question. So we found that to be 68. This was 47.5. Now, if we go a little further than that, there's 47.5% in that shaded thing. If I subtract 34 from that, I get 13.5. That tells me that there, let me get an eraser for a second. That tells me that there is 13.5 right here. And there's 13.5 over here. I apologize, this is a little clunky. My tablet that I usually use to do this is not working right now. So let's move on. What percentage between 60 and 80? Well, 60 and 80, we've already answered that. That's the 95%. Because, 65, 60 and 85, this is where it would be useful to shade it. So let's think about that. That's 60 all the way up to 85. Well, I just need to know this. So it's 95 plus, because it's 95 from 60 to 80. But what about from 80 to 85? Well, remember that 99.7 rule? If I take that 99.7 and I divide it, well, and I subtract the 95, that gives me 4.7. If I take that 4, then 4.7 is the area in this tail right here and this tail over on the left between 55 and 60. If I take that 4.7 and split it into 2 to account for 2 tails, 4.7 divided by 2.5. Now, if you copy down that whole distribution from the previous slide, you already have this. This is not by 2.5, you dingling, just by 2. I'm getting ahead of myself. 47 divided by 2, 4.7 divided by 2 is 2.7. 2.35. So there's 2.35% right here. And for the same reasoning, there was 0.15% out here. There was 2.35% here. I'm going to just label it all. Now that I've calculated it all, I might as well label it all. So 95 plus the 2.35 gives me 97.35. So I've got 97.35% of those freshmen scored somewhere between 60 and 85%. Let's look at something else. How about less than 55? Well, less than 55, that's way down here. That's that 0.15. That 0.15 comes from 100 minus the 97.5, and then you divide that by two tails. What about greater than 80? Well, greater than 80 would be right there. That's just this 2.35 plus the 0.15. That's going to be 2.5. So as soon as we have these percentages all labeled in our curve, all of a sudden it's just a matter of seeing which pieces it gets to. That's what we're looking at. That's the power of that normal distribution. If I know those couple of characteristics about the sample, about the population, I can tell you what percentages were between different values. That's what we're looking at today, guys. So you should be able to identify a normal distribution as bell curved, as following that 68, 95, 90.7 rule. So here, your turn for a second. ACT scores are about normally distributed. 1 year they had them between 21 and 5.2. Okay, so think about this. Pause it for a second and look at the questions. Go. Okay, now that you've unpaused it, what's the interval that contains 95% of the scores? Well, that's going to be 21 plus or minus 2 standard deviations. And a standard deviation is 5.2. So that's 2 times 5.2 is 10.4. So 21 plus or minus 10.4. 21 plus 10.4, that's 31.4. 21 minus 10.4. I don't want to do that in my head right now. I'm not going to. So I'm just going to turn my calculator. 21 minus 10.4. Well, that gives me 10.6. So 10.6. So that tells me that 95% of those ACT scores were between 10.6 and 31.4. Okay, that works. Now, what's the probability? What's the probability that an ACT score is less than 26.2? Well, 26.2. Well, there's 21. 5.2 would be one more. That would be 26.2. Well, that's going to be all the way, all of this right there, and plus this. Well, anything below the mean, that's 50%. Plus the 34, that's 84%. Oh, so 50 plus 34, 84. So 84%. Let me erase some of the scribblings that I just did. What's the probability that it's greater than 31.4? Well, where's 31.4 on my distribution? 26.2 plus the 31.4, that's going to be right here. 31, that's 2 standard deviations. Well, 50 plus the 34 plus 13.5, if I add that and that and that, that gives me 87.5. So there's an 87.5% that it's below. Oh, you know what? If I did 100 minus that, that would have given me 12.5. No, it wouldn't. Not 87, that's 97.5. Goodness sake, 97.5. I've got to add these things together. So not 12.5, but 2.5. I guess another way, this would have been easier. Why didn't I just add this 2.35 plus the 0.15 that you see out on the little tail? I could have done that. So if you have just a note card or something with these labeled on, so you don't even have to find them the first time, this isn't too bad. If there are 650 juniors who took the ACT, how many scored better than average? Well, if you're thinking it's going to be symmetric, that means about half are going to do worse than average, half are going to be better. So half of 650 is 325, and there it is. Okay, if that's what you got, great. If it's not, review what happened and go for it. Now, guys, the practice work is very, very similar. Let me give you a heads up. Remember the 68, 95, 99%, 99.7% rule? Have these percentages somewhere in your notes. Every time you get a problem that deals with normal distributions, label your mean and label your standard deviations out there. I might even put the percentages in there and go from there. Good luck, guys, and have a great day. Bye bye.